Distance and midpoint between polar coordinates. Your learning goal is that you'll be able to represent complex numbers and their operations on a complex plane. So you'll be given two polar points, and I suggest you label them as r1 theta 1 and r2 theta 2. And then to find the distance between them, you use this formula. D equals r1 squared plus r2 squared minus 2 times r1 times r2 times cosine of your second angle minus your first angle. And then to find the midpoint between the 2 points, remember midpoint is an ordered pair, and since x represents cosine, you're going to do r1 cosine of theta plus r2 cosine of theta 2, that's theta 1, all divided by 2, comma, your y-coordinate is sine, so you're going to do r1 times sine theta of 1 plus r2 times sine theta of 2, and all of that is divided by 2. So once you get those two values, that would be your midpoint between the 2 points. Example 1, we're going to find the distance and midpoint between these two polar points. And what I do first is label this r1 and theta 1 and r2 and theta 2. So first we'll do the distance. So I'm just going to plug everything in my formula. Remember, you do r1 squared plus r2 squared minus 2 times r1 times r2 times cosine of theta 2 minus theta 1. And you're going to type all of that in your calculator. And I'm going to give you a second to type that in to see if we get the same answer. Okay, you should have gotten 6.33 units. And if you didn't, two things could have happened. Make sure your mode is in degree mode, since those are degrees. And then another thing that might have happened, your calculator probably gave you a square root to start, so you're going to have to put a double square root if that happens, and then try it again and see if you get the right answer. So now we're going to move to midpoint, and we're going to use the same 2 points, and we're just going to plug those in. So the midpoint formula, you do r1 times cosine of 135 plus r2 times cosine, I used the wrong one. Let's try this again. r1 times cosine of theta 1 plus r2 times cosine of theta 2. And when you get that answer, you're going to divide by 2. And then to get the y-coordinate, you're going to do r1 times sine theta 1 plus r2 times sine of theta 2, which is 135. You get that answer, you're going to divide by 2. Okay, using our unit circle, cosine of 30 would be radical 3 over 2. plus cosine of 135 is the same thing as cosine of 45. It's just negative. Divided by 2. And then to do our sine values of those same angles, sine of 30 is 1/2. And sine of 135 is positive radical 2 over 2. And we're going to divide that answer by 2. So simplifying, 2 goes in the 6 3 times. Same thing over here. So we have radical 3 over 2 minus 3 radical 2 over 1 divided by 2. And then over here we have 1/2 of 1, which is 1/2, plus 3 radical 2 all over 2. And what I'm going to do is just multiply everything by 2. So that's gone. And I have radical 3 minus 6 radical 2 over 4. And then my y-coordinate will be 1 plus 6 radical 2 all over 4. So sometimes they're not going to come out nicely. But just make sure you don't have a fraction over a fraction. Okay, we're going to do one more example where we actually have radians. So first I'm going to find the distance. And you do the same setup. So you do r1 squared plus r2 squared minus 2 times r1 times r2 times cosine of theta 2 minus theta 1. Oh, I forgot to label. Don't forget to label your coordinates. R1, theta 1, R2, theta 2. Okay, so then I'm going to simplify. That's 9 plus 4. And the reason why I'm doing this is because it's in radians. My other problem wasn't. And multiplying all of those, I get negative 12 times cosine. My denominators are already the same, so I can subtract negative 6 pi over 6, which is equal to negative pi. So far I have 9 plus 4, which is 13, minus 12 times cosine of negative pi. Alright, cosine's coordinates, remember, pi's coordinates are negative 1 and 0. We need cosine, which is negative 1. So that'll be 13 minus 12 times negative 1, which makes it a positive 12, which makes it square root of 25, which is a nice one because that's a perfect square. Okay, then the midpoint. Remember the formula is R1 times cosine of theta 1 plus R2 times cosine of theta 2 all divided by 2. Then you do your y-coordinate. R1 times sine plus R2 times sine, and all of that is divided by 2. Okay, 11 pi over 6 is the same as pi over 6, and it's in the 4th quadrant. And remember, pi over 6, cosine would be radical 3 over 2 plus negative 2 times 5 pi, cosine of 5 pi over 6. Now 5 pi over 6 is in quadrant 2, so it's going to be negative. But it's still radical 3 over 2. And then my y-coordinate, I'm doing negative 3 times 11 pi over 6. Now this one's negative because it's in the 4th quadrant. And this is going to be 1/2 plus negative 2 times sine of 5 pi over 6, which is also 1/2, but this time it's positive because that's in quadrant 2. Alright, I'm going to move to the next screen because I'm running out of room. Okay, this is what we had on the previous screen, so now I'm just going to simplify. So in my numerator I have negative 3 radical 3 over 2. And these two negatives make a positive. Actually, the 2's cancel out. Plus radical 3 over 1 all over 2. And then over here we have these two negatives make a positive. 3/2 plus, well actually it's going to be minus 1 all over 2. I'm going to do like before and multiply everything by 2. That way we won't have a fraction over a fraction. So we have negative 3 root 3 plus 2 root 3 all over 4. And over here we have 3 minus 2 all over 4. So simplifying my numerator, sorry about that, I'm going to get negative 1 root 3 over 4, comma 1 over 4. And there's my midpoint.